In the last lecture, we gave an introduction to global climate change, and I want you to clearly understand the difference between local and global, okay? Because there is a lot of confusion between local climate change and global climate change. Okay? Global climate change are caused by changes in ice cover, clouds, gases that absorb earth radiation, changes in incoming solar radiation, and volcanic eruption. Local climate change are of course influenced by global climate change, but they are also influenced by local factors such as change in wind direction, changes in land use pattern. Suppose you convert a local area from a forest to a built up area, you will change the local climate. And of course, air pollution. Air pollution affects local climate dramatically. Okay? So, when you look at local climate change, you must realize that it is more complex. We will not discuss that much in this course because that requires more understanding of local factors. This course will be focused only on global climate change because it is simpler to understand, and you need to master that before you try to understand local climate change. Okay? Now, you look at global climate change, you must first look at what happened in the last 20,000 years. Now, remember that thermometer was invented only about 300 years ago. Before that, we did not have a thermometer. So, how do you know the temperature over the last 20,000 years? We use something called proxy data, indirect measurement. And based on that, they were able to show that the earth was much colder 20,000 years ago, okay, which is here. 20,000 years ago, the global mean temperature was around 8 degrees centigrade. Today, it is 15 degrees centigrade. So, we came from the last ice age 20,000 years ago and rapidly warmed up to the present climate around 10,000 years ago, and we remain at almost constant temperature from 10,000 years ago to 1850. From 1850 to today, we saw in the last lecture that temperature has gone up by 1.5 degrees. Now, the question is, how come the earth had almost constant temperature for 10,000 years and then suddenly started warming up? The reason is, between 10,000 years ago and 1850, human beings had no impact on climate. We did not use coal, oil or gas. We were burning only firewood and a few local fuels, and so we did not have an impact on global climate. And natural factors kept the temperature constant for almost 10,000 years. This is called a climatic optimum, and because the climate was very steady for 10,000 years, agriculture thrived. Agriculture does well only under constant climate. So, because climate was constant, agriculture thrived and human population increased rapidly during this period. Remember that 20,000 years ago, farming was not possible. Earth was too cold and only hunter gatherers lived, who lived in caves, and they hunted various animals. Okay? But once the earth became warm, agriculture was possible and human population started increasing because of availability of food. Now, in the last 150 years, because we started burning oil, coal and gas, we started increasing temperature more rapidly. And we need to be concerned about that, because if we continue to do that, temperature will increase even more rapidly. Okay? And that is the focus of this course. How temperature is changing rapidly in the last 150 years, and what are the causes, and what can we do to mitigate this rapid warming. Now, when you look at the past climate, we cannot use thermometer. So, we use various proxy data. Proxy data are biological, physical or chemical quantities which you measure from sediments, fossils, shells, from ice cores, from air trapped in ice cores, and from caves where you have speleothem, that is sediments formed within the caves through which we infer temperature or rainfall change. Also from corals on the ocean floor. Okay. These are called archives. So, these are surrogates for climate, that is, we cannot measure temperature through thermometer, which are not there in the past. So, from various other sources we infer temperature or rainfall by indirect means. This is not very accurate, but using various techniques we can get a rough idea what was climate, for example 20,000 years ago. Okay. So, this is the only method we have to infer past climate. Now, from this proxy data we know Earth was once completely ice free millions of years ago, and it was also completely ice covered, called the snowball Earth. So, the fact that Earth has oscillated between an ice free Earth and an ice covered Earth should bother us, which means Earth climate is not stable. It can change. The fact that it did not change between 10,000 years ago and 1850 should not cause us to be complacent. We should realize that Earth's climate is not stable. It has changed a lot in the past 100 million years, in which we have some proxy data, and we have to understand why did this climate change from an ice covered Earth to ice free Earth, whether such a change can occur in the future due to human actions. Okay, that is the main focus of this course, to understand both the past climate and also how climate may change in the future. Now, why is that important? Because we were in the last ice age 20,000 years ago. Then something happened which caused the Earth to shift from the ice age to the present climate, which is warmer by about 8 to 9 degrees, and it occurred fairly rapidly, and that rapid change is called the tipping point. The Earth goes through some changes slowly, but sometimes it changes rapidly, and with rapid change the Earth changed from one state to another state in a matter of few thousand years. Now, the concern we should have is, because we are influencing the global climate, can we change the present climate to a much warmer climate by passing through a tipping point? So, the focus of this course is whether the changes that we are reducing due to human actions, can they cause it to go to a much warmer climate? At present we do not know whether it can happen, but in the Paris Agreement signed about 10 years ago, the concern was that the 1.5 degree warming we have already caused could tip the Earth to a much warmer climate. So, the agreement in Paris was that we should try to restrict the warming to within around 1.5, because if we increase it much further we may go past this tipping point. We do not know exactly where the tipping point is, but we have to be cautious that tipping may occur because it occurred in the past. In the past the temperature tipped from an ice age to the present climate, which suited our agricultural society, but now we are doing changes at a much faster rate. It is possible that we will shift to a much warmer climate. So, this will be one of the focus of this course, to understand the possible tipping point in the Earth's climate. Now, let us look at carbon dioxide, which is one of the gases which has a major control on Earth's climate. If we look at the carbon dioxide over the last 200 years, where we have good data, we have seen that the concentration of carbon dioxide increased from 280 parts per million around 1750 to around 380 parts per billion in the year 2000. This rapid change occurred because of the burning of coal, oil and gas. Now, if you compare this with the change that occurred over the last 10,000 years, okay, we see that the change was not much from 8000 BC to around 850 AD, in which the change was around 10 to 20 ppm, a slow change. Then we see a very rapid change. So, we need to understand what caused this gradual change before 1850 and a much more rapid change after 1850. Notice that in the 150 years from 1850 to 2000, the amount of CO2 increased from 280 to 380, 100 ppm. But in the previous 10,000 years, the change was hardly 20 ppm. So, you can see that the changes occurring today are much more rapid than what we saw in the past. This is the main concern. People always ask, why worry about a change of a few ppm or a few degrees centigrade? The reason is this change is occurring more rapidly than in the past. Now, how did it come to know about the past? This was due to drilling of the glaciers in Antarctica. There are ice sheets which are 4 kilometers wide, very thick ice sheet, and they went and drilled and got a sample of this ice core, and ice core contains the history of Earth's climate. Okay? And when snow falls in these polar regions, they settle down and slowly the snow is compressed, and we go about 50 meters below the surface. The air that was there at that time is completely trapped by ice, and this air contains the information about the past climate of the earth. Okay? So, scientists have drilled ice cores and tried to identify what changes are going on in these air sealed in the ice. So, this is a source of very valuable information we have about the past. Okay? Here is a ice core in which you can see air bubbles. These air bubbles provide information about past climate. Now, this tells us that there was a carbon cycle, carbon dioxide change in the past also due to long term carbon cycle, and these cycles were over a time scale of 100,000 years to a million years. It is a very slow process, but Earth maintains balance by slow changes in the carbon dioxide in the atmosphere. Okay? Carbon dioxide is added to the atmosphere through volcanic eruptions. Volcano releases carbon dioxide, and also it is also released in mid-ocean ridges. Okay? But rain dissolves the carbon dioxide and ultimately converts carbon dioxide into limestone, calcium carbonate. Okay? So, in this cycle, CO2 is released by volcanoes and it goes back into the ocean and into the ocean as calcium carbonate after dissolving in the rainwater. Okay? The shifting of the plate due to plate tectonics causes sediments to heat up, and that releases CO2, which comes back into the atmosphere through the volcanoes. So, the large scale variations in the Earth's climate are due to slow changes in the carbon dioxide cycle, but this cycle now has accelerated due to human actions. Okay? So, now CO2 released by burning of coal, oil, natural gas not only increases the local concentration of CO2, but travels around the world and causes an increase in carbon dioxide everywhere. So, this is why we have to worry about global temperature, because carbon dioxide release anywhere in the earth, whether it is in Bengaluru or New York or Beijing or London, ultimately they go around the earth and the winds take CO2 to every part of the earth, and so CO2 increases everywhere. So, the carbon dioxide concentration is increasing everywhere on earth, although it is released by human actions only in a few places on the earth. Okay. A part of the CO2 released by human beings is absorbed in the ocean, another part is utilized by plants in photosynthesis, but about 50% remains in the atmosphere. Okay. And that is what has caused an increase in carbon dioxide from 280 parts per million to 426 ppm in 2024. So, you can see that human actions have increased the global mean carbon dioxide by more than 140 ppm in the last 170 years. So, this is a big impact human activities had. Now, notice that if you look at emissions by individual countries, they are not same. Right now, China is a country which is emitting a lot of carbon dioxide. Next is Europe, and then carbon dioxide, then United States, then India. But remember, it does not matter who is releasing the carbon dioxide. Ultimately, it reaches everywhere. It has a global impact. So, that is why we are focusing on global temperature change, because it does not matter who releases the CO2, which country releases more, which country releases less. Ultimately, it affects all of us. That is why there is a need for global negotiations to control the amount of CO2 emission, because CO2 emission is going to cause global warming at a rapid rate. Now, we have the evidence of that. We have measured carbon dioxide in a place called Mauna Loa in Hawaii. Very accurate measurement has been done, and that shows from 1958 to today, carbon dioxide has increased steadily. Okay? But notice that there are seasonal cycles, small seasonal cycle. This is due to photosynthesis. During the northern hemisphere summer, when a lot of land region vegetation increases, it absorbs carbon dioxide. So, CO2 temporarily goes down by a few ppm. But because we are releasing CO2 due to burning of coal, oil and gas, it continues to increase rapidly. So, this accurate measurement of carbon dioxide over the last 160 years has told us clearly that this increase is not due to natural causes. This increase is only on account of burning of fossil fuels. This can be shown very clearly. For example, all of you know that when I burn a molecule of carbon with oxygen, we will get carbon dioxide. So, when carbon is burned, it consumes oxygen. The burning of carbon will result in reduction in oxygen atmosphere, and scientists have been able to measure very accurately the decline in oxygen in the atmosphere. Okay? The decline is not much, is very small, 0.001%, but that is exactly equal to the amount of carbon you are burning. So, you are able to do exactly a budget showing that for every ton of carbon dioxide measured, how much oxygen has reduced. So, this shows clearly that the increase in carbon dioxide in the Earth's atmosphere in the last 160 years is only on account of burning of fossil fuels. Okay? So, a very accurate measurement of both carbon dioxide and oxygen has proven beyond reasonable doubt that the increase in carbon dioxide is not due to volcanic eruption or other natural causes, but on account of burning of fossil fuels. This is important proof which was required to convince many skeptics who thought that increase in carbon dioxide may be due to natural causes. It is not. It is mainly on account of burning of fossil fuels. Okay? Now, global temperature in the last 100 years has increased 10 times faster than in the last 20,000 years. In the past, carbon dioxide increased due to natural causes by about 20 ppm in 100 years. Today, CO2 is increasing by 20 ppm in 10 years. Okay? So, you see that both the CO2 increase and the temperature increase is 10 times faster than in the past. This is what is concerning everyone, because this clearly shows that what we are doing in burning fossil fuels is unsustainable. It will cause major disasters and major climate changes which will cause major harm to all human beings. That is why the Paris Agreement was arrived at, because people realize that what we are doing is not sustainable and we have to do something different to control this rapid increase in carbon dioxide and temperature. Okay? Now, the Earth climate system is very complicated. The temperature of the Earth is controlled not only by carbon dioxide, but also by radiation coming from the sun. It is also controlled by ocean circulation, it is controlled by clouds, controlled by ice sheets, the cryosphere, controlled by vegetation, the biosphere. All these are controlling the Earth's temperature. But remember that we cannot in the first course on climate change cover all these factors. We will cover only some of them which are very important. Okay? So, the Earth system is complicated. We have to simplify it to understand how we are influencing climate, and after understanding what factors control global climate change, we will be better able to understand local climate change, which is more complex than global climate change. Now, I want you to understand that Earth's climate is influenced by broadly 6 major factors. One, of course, is sun, because sun supplies energy to Earth's climate, so it has impact on Earth's temperature. Volcanic eruption also has an impact on Earth's climate. Changes in Earth orbit around the sun, which we will discuss in detail later in the course, will also influence Earth's climate. Changes in the composition of atmospheric gases and aerosols, which are small particles in the atmosphere, they also influence Earth's climate. How continents are located, how they are distributed in the Earth's surface will also influence the temperature, and so do clouds and ice. So, all these factors influence, and so we have to simplify the Earth's climate system to understand how each of these factors influence our climate. Okay? Now, to understand global climate change, we have to understand the balance between the radiation absorbed from the sun and the radiation emitted by the sun to space. So, this balance between absorption and emission controls the Earth's temperature. So, the major focus of this course will be on how this balance is altered by the gas in the atmosphere, by clouds, by ice cover, and of course by gases. So, this is the major focus, how the global mean temperature is altered by the effect of many of these factors. So, what you have to understand is the global mean temperature is controlled mainly by carbon dioxide, with water vapor acting as an amplifier. Water vapor is also equally important, but it mainly acts as an amplifier. You will know why in the subsequent lectures, because the amount of water vapor on the earth is controlled by CO2. Because CO2 affects Earth's temperature, the Earth's temperature influences the amount of water vapor. Why is the Earth's water vapor controlled by temperature? This is governed by a well-known law called the Clausius-Clapeyron equation. From thermodynamics, we know that the amount of water vapor in the atmosphere is influenced by temperature. So, water vapor in the Earth's atmosphere will not remain constant if temperature changes. So, this factor is very important to understand. The water vapor is completely slave to the temperature of the Earth, which is controlled by carbon dioxide. This unusual factor was not understood for a long time, and people didn't realize that carbon dioxide is a major factor which controls the Earth's climate. Water vapor is a slave to the control exerted by carbon dioxide. So, these and other issues we will discuss in the subsequent lectures in this course, but this main idea that carbon dioxide is a major control of Earth's climate should be understood by you, and that is why we focus a lot on the role played by carbon dioxide. In the next class, I will talk about radiation heat transfer and also talk about textbooks we will be using to understand radiation heat transfer in the Earth's atmosphere.